Okay, hey kids, time for another parabola lesson. So this is our third and final installment of come up with a different way to represent a parabola graphically. So I'm just going to show you what I have here on Desmos that I want you to look at. So here we go. We've got Desmos here, and we can look, if I type in any quadratic equation, so I'm just going to type something in. I'm not totally picking this at random because I want the numbers to work out well, but I'm going to choose something here. I'm going to type in x squared plus 3x minus 4. If you're looking at this, you can see obviously that I have made a parabola, and the numbers I chose here, this is actually a trinomial that's factorable. The reason I chose that very specifically is I wanted to show you that we can in fact write this as its factored form, x plus 4 and x minus 1. If we do this, we can see that the purple factored form overlaps the original here. So they're the same quadratic equation because one is just a different form of the other and they make the same parabola. So this just actually shows that we can express a parabola in a different form, which is the factored form. So you might be sitting there going, well, what's the point of that? But this is actually a pretty useful thing. These 2 points are very important. These are the x-intercepts, and sometimes we want a parabola to go through those points, and we want to be able to maybe modify it from there. So if I put a out in front, what I can do is I can change a, which is going to change the shape of the parabola, but it's always going to be forced through those 2 points, and the 2 points are, of course, -4 and 1, which are the solutions to my quadratic equation if I set it equal to 0. So this is just another form of writing parabolas. It's different than the vertex form. The vertex form tells us exactly where the vertex is. This tells us not where the vertex is, but it tells us where the x-intercepts are, and I can mess around with it. This value of a is just like it's always been. It's a horizontal compression or vertical expansion, depending on how you want to look at it, but it's always going through those 2 points. So we're going to look at this, how you get from one to the other, and the importance and use of this guy in this lesson today. All right, so let's get going. So 4.6, quadratic functions in factored form. So this is the general form for how we're going to write. Well, I should be careful with that word general because general form actually means something very specific, but this is how we're always going to write the factored form. The general form, just remember, is this guy here, ax squared plus bx plus c. That's the general. So when I say general form, that actually does mean something very specific. This a here and this a here, again, are the same. So that a is interesting because that's the only guy who actually survives the different conversions between general, vertex, and factored form. X1 and X2, those are the x-intercepts. So keep in mind that this x is the independent variable, y is of course the dependent variable, and these guys are some fixed values. So if it crosses at -4 and 1, like it did in the last example, x1 and x2 would be -4 and 1. The equation of the axis of symmetry is halfway between x1 and x2. That's simply because if you have a parabola and you have 2 x-intercepts here, and it's, let's say it's a happy guy, well, we always know the axis of symmetry is exactly between 2 points on the same y-coordinate, and well, that would be the condition for these 2 x-intercepts. So one thing we can do is we can find the vertex of this guy here. It's not in vertex form, so we can't simply look at it, but we can figure it out. So if we want to find the vertex of this, we can simply say, okay, so x1 is equal to 1, and x2 is equal to -3. Keep in mind that the factored form requires them to be minus signs in between, so if you've got a plus sign in between here, you've got to switch the sign, which is something we're getting pretty used to doing, I think. So how do we find the axis of symmetry? If you want to do this mentally, you probably can, but if you want to actually figure this out with a formula, how do we figure out halfway between x1 and x2? We're actually going to say x1 plus x2, and we're going to divide it by 2. Halfway between the points is simply finding the average, and this is how we find the average. So we can say x1 is 1, we can say this is -3, and then we can divide it by 2. Common sense might tell us it's got to be at a certain location here at -1, I believe, but we can also work this out. So it's -2 over 2, and that's equal to -1. Okay, so this is the x coordinate of the vertex. So if we want to find the y-coordinate, well, we simply can put it back into our equation and we can calculate the value of y. So now we're going to take this, we're going to stick it in y equals 1/2. And instead of x minus 1, I actually know the value of x I want to put in. So I'm going to put that in. So this is 1/2, this is -2, this is +2. I can do a little cancel. 1/2 and 2 cancel out, so I'm going to get -2. So what this tells me is my vertex is at -1, -2. And if I think about this just for common sense, if I had these 2 points, like here's 1 and here's -3, and it's upward facing because this is positive, I could imagine a parabola kind of going something like that. And this seems like a pretty reasonable logical place for where the vertex would have to be. Okay, so we cannot get the vertex directly from the factored form equation, but we can fairly easily figure it out. Oh shoot, well okay, this is coming up in the opposite direction, but okay, anyway, the vertex isn't directly given, but it lies on the axis of symmetry. Okay, anyway, I'm going to have to double check that, I guess, in the future. Okay, here's an example, vertex versus factored form. So convert this guy into factored form and vertex form and then graph. Generally, graphing this guy, which is the general equation, this usually kind of sucks. So we're going to either favor factored or vertex form. I can't say for sure which one is better because they're both pretty good. Maybe I have a slight preference for vertex, but let's see how both of them go. So if I want to convert to factored form, it's pretty simple. In fact, it's actually in the name you have to factor this. Now you might be thinking, well, what if I cannot factor it? And that is definitely a possibility. You cannot factor every single trinomial, therefore you cannot write the factored form for every single trinomial. All you can do is sometimes you'll just not be able to actually write the factored form. You can, however, always do vertex form. So for that reason, it might even be the best choice overall. Okay, so if I'm going to factor this, let's see here. It's been a while since I've factored, so I'm not going to guess and check. I'm going to use decomposition. So I'm going to be thinking to myself, what is AC? AC is 2 times 2, which is 4. What are 2 factors of 4 that add up to the middle number, which is 5? And that's going to be -4 and -1. So this is going to get factored like this. -4x minus x plus 2. Y equals, here's 2x. X minus 2, and here I'm factoring the -1 to get x minus 2. So the factored form, which you get simply by factoring, is going to look like this. Now if you stop right here, that's the 2. If you stop right here and you leave the 2 inside the brackets, that's technically not quite it. You notice the factored form requires, I'm just going to jump back a sec, the factored form requires x's to be by themselves and a to be out front. So that's something we've got to make sure that we do in this case. So we're going to go one step further. The 2 is going to come out of the first bracket, and we're going to have x minus 1/2, and then x minus 2. That is factored form. Let's write a tiny little note. That's a weird star. Always get x's isolated by factoring out any coefficients. Okay, so this tells me that my x1 is equal to 1/2 and x2 is equal to 2. So if I wanted to plot this bad boy, I could go ahead and do that right now, and in fact, why don't I do it? So I can see my spacing here. I'm going to space, so let's make this 1, let's make this 2, let's make this 3. And I'm going to do something similar here. -1, -2, -3. 1, 2, 3, -1, -2, -3. I don't know why I put that mark sideways. Okay, so plotting this here, I know I've got two x-intercepts, so I can go ahead and I can change my color, and I can say one of my x-intercepts is here at 1/2, and the other one is here at 2. I don't know where the vertex is, so to get the vertex, I'm going to find the axis of symmetry, and remember that's x1 plus x2 over 2, so that's 1/2 plus 2 over 2. So 2.5 divided by 2 is 1.25. I know I say don't do decimals, but I'm going to use a decimal in this case. So that's x equals 1.25. Y, therefore, is equal to 1.25 minus 1/2, and 1.25 minus 2. So this will be 1.25 minus 1/2. I'm going to think decimals here, so that's like 0.5. So that's 0.75. This might be going terribly. I might want to convert back to fractions. This one's going to be negative 0.75. Okay, it turns out I don't want to multiply 75 and 75, so I am actually going to convert back to fractions. 75 is 3/4. This is negative 3/4. So let's see. 3 times 3 is 9, times 2 is 18, 4 times 4 is 16, and I'll reduce it to get this negative sign up front. That will be 9 over 8. Okay, so negative 9 over 8. So 1.25 and negative 9 over 8. So if I actually do this here, 1.25 is there, negative 9 over 8. That's just a tiny bit below there, so I'm going to actually mark that. 1.25 comma negative 9 over 8. Oh, this is upsetting me too. 1.25 is a fraction, it's 5 over 4. This looks a little nicer. Okay, there's 5 over 4. Anyway, so now that I have my vertex and I have my x-intercept, I can go ahead and I can sketch. It's not mandatory that you do this absolutely perfectly, but try and get a nice little bit of curve there. Okay, so that's the factor form. I need to do vertex form, and did I leave myself enough room? I don't know. Let's see if it'll fit. So you actually should be able to figure out what vertex form is, but I'm not going to just assume that I did everything right. I'm going to do this using steps, and it's a good review. So vertex form would be y equals 2x squared minus 5x plus 2. Remember, in vertex form, you're factoring this guy out. You're leaving this here, you're taking the 5 over 2, you're dividing it by 2 and squaring it. So that would be 5 over 2 times, divide by 2. So that would be 5 over 4. And we square that to get, what's that, 25 over 16? So plus 25 over 16 minus 25 over 16 plus 2. So as some people have pointed out, there is a shorter way to do vertex form here, and if you figured it out, that's fantastic. I'm a really big fan of doing it the long way, and if you want to start discovering shortcuts for yourself, I think that's really, really useful, but I'm a little hesitant to jump to them right away. Let's see, we'll multiply this last guy here by 2, so that'll come out as negative 25 over 8. And then instead of adding 2, I'm going to add 16 over 8 because I'm going to have to do common denominators eventually. Okay, so then this becomes y equals 2. I'm going to collapse down that trinomial to x minus 5 over 4, all squared, and then 25 over 8 plus 16 over 8 is negative 9 over 8. Hallelujah, that's exactly what I got for my vertex here. There's P equals 5 over 4, and there's Q, which is negative 9 over 8. I personally think it was actually more work to put it into vertex form here, and well, that just overlaps with my factored form. So factored form kind of made sense in this case, especially because it was factorable. If it wasn't factorable, it would be a different story. Anyway, I'm not going to graph this because it's just going to overlap, but these two are the same. Okay. Just for the record, I did mention a shortcut. I'm just going to jump over here and I'm just going to show you what the shortcut is. Now the thing about shortcuts is you have to remember them. So the shortcut, and if you did your homework, you would have found this out, I believe. The shortcut to find the vertex. So if you actually do y equals ax squared plus bx plus c. So any general form, and you want to go directly to y equals ax minus p squared plus q. There is a way to calculate what p and q are from these guys without doing a lick of serious algebra. I'd like to show you where the shortcut comes from here, and if you've already seen it, you can just fast forward a little bit, but I'd like to actually show you. So let's go through the process of completing the square. So we're going to do this. We're going to do this. So b over ax. Now we have to go, okay, well, remember this whole term in the middle is b, so b over 2. So what has been called b over 2 squared b. I know we're using b there and then b here, so it gets extra confusing, but that's like b over 2a and then squared, that's b squared over 4a squared. So if we actually add and subtract that, b squared over 4a squared, of course we have to subtract, and then we have c on the outside. We will then multiply this guy here by a, times it by a to take it out. So that's going to come out as minus b squared over 4a, and then we've got a plus c here. Okay, so then this whole thing collapses down into this. Remember, this term is half of the middle, or it's the square root of that, either one. So the ones that be b over 2a, and then this guy over here winds up being, let's look at it like this, minus b squared over 4a. I'm going to say plus negative b squared over 4a plus c, okay, just to make it look a little bit more normal. So here's my value for p. P is b over 2a, and then q, and dear Lord, I don't know a single human being who remembers this, but, well, there it is, okay? Some people might be going, I'd prefer if you did a common denominator, so it looked a little nicer, so we can actually do that for AC. This is 4a, so then this becomes negative b squared plus 4ac all over 4a. Okay, so this is my value for q, and if this looks kind of familiar, that is not at all a surprise, because this looks an awful lot like the discriminant, and there's a very good reason for that. Anyway, no one remembers q, but everyone remembers this, so I would actually highly recommend memorizing this, because if we want to just turn something into vertex form, we can say b over 2a is the value for p. Now I'm just having a little moment here where I'm realizing I made a tiny mistake, and I actually realized what my mistake was. We had plus signs all the way here, and then for some strange reason I switched it to a minus sign, so we're going to make that a plus sign. And we're actually just going to correct this a little bit because my memory was telling me there's a minus sign in front. So there you go. So don't memorize what I just said, memorize this one. P equals negative b over 2a. All right, so let's jump out of that. Let's just see if we could have used that as a shortcut. So if I wanted to figure out p, I could have used the formula negative b over 2a. Would that have worked? This is b, so that's negative 5 over 2, there's a, so 2 times 2, and that would have given me positive 5 over 4, and that's exactly where my vertex is at. Okay, so congratulations, that is the shortcut. I believe that was one of the C-level questions in the last homework, but if you haven't done it, well, I'd like you to see that then. Okay, there you go. I'm not going to bother checking Q, because no one remembers that one. Okay, the other thing we can use this for is solving a lot of problems. There's a fair number of problems in the book, and possibly even real life here, where you've got information where you're not given a vertex, but you're given some other useful stuff like the x-intercepts. So let's just look at this one. Football's kicked in a parabolic arc. By the way, everything in the air travels in a parabolic arc. Parabolas are everywhere. It reaches a height of 32 feet and lands 40 feet away from the kicker. Determine the equation, blah, 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 blah. Okay, so it's a pretty standard sort of question. The big thing you have to do is decide how you're going to set this up mathematically, because now we've got a situation where we've got a real life, I'm going to use the air quotes there, a real life situation where we don't have a coordinate system, but I'm going to put this on top of a coordinate system. So I always think of it as, here's the kicker. I tend to like them at the origin because that's the starting point, and that just seems natural to me. We know the ball hits a height of 32 feet, and we know it lands 40 feet away from the kicker. I'm sorry for those of you who are really excited about metric, but it just isn't going to happen today, I guess. So it goes 32 feet in the air, and it comes back down, and it lands at 40. So what we can do is we can look at this, and we can determine an equation. Now, I didn't say specifically to use vertex or general or factored form, but this is less on factored form, so we might as well use it. And this actually tells us some pretty good info. This is what I would call x1, and this is what I would call x2. We have the x-intercepts directly, so I'm actually going to go ahead and I'm just going to jump to factored form. This actually seems to make the most sense to me right now. Okay, I don't know what a is. X is a variable, and I do know that x1 is equal to 0, so I can write x minus 0. And this one I'm going to write x minus 40. Okay, so there's y. What does this 32 have to do with anything? So those of us who've been paying attention know that this actually corresponds with a point halfway in between the two. So this is located at 20, 32. So we could have actually wrote that down and went straight to vertex form, but again, I'd like to do factored form for this one. What is the significance of this point here? If you actually think about it, and this is where it's actually really worth it to just jump out and look at Desmos. I can have a lot of different parabolas that go through the points 0 and 40 for x-intercepts, but only one specific one will go through 20, 32. If I actually just go to Desmos here and I type in y equals x minus 0 and x minus 40, and I make it visible. There's my parabola. It goes through 0 and it goes through 40, but it kind of does something weird. That's not the shape of a parabola that I want for this. So I put some value a in front, and what the value a in front does is as I change that value of a, and I'm going to zoom in a little bit here, as I change the value of a, that actually changes my parabola's shape. It doesn't change the intercept, so I could have an infinite number of footballs that I kick in the air and land 40 feet away from me, but the one that very specifically goes to a height, oh, okay, well that's what happens when I put on the automatic slider. The one that very specifically goes 32 feet in the air, I'll need to pick just the correct a value. So we can actually see here it's got to be negative because it's going to be a downward sad parabola, and it's got to go through the point 0. Sorry, not 0, but it's going to go through the point 20, 32. Okay, so let's actually, let's try to fix that. And if I put a label there, I can see the point 20, 32. I'm going to have to zoom in a little bit, and for some reason, it just isn't letting me see anything. Let's just add a slider. There we go. Okay, so I need to modify this value of a so that it goes just through that point, and oh, that's pretty close. So what I need to do is I need to solve for it exactly. I can't just sit here and trial and error it with Desmos all the time. We want to get a better way of doing it, so I'm going to jump over here. I'm going to solve for a. So just like before, if I need to solve for this guy, I'm going to solve by subbing in 20, 32. Okay, so the value of y would be 32, the value of x would be 20. So we get 32 equals a, this is 20, this is negative 20, so that's 32 equals a times negative 400. So a is equal to, let's see, 32 over negative 400, which I know reduces. So let's see, I'm going to, that's 16 over, no, that's 8 over 100, no, that's 2 over 25. Okay, so negative 2 over 25 should be my value of a. That forces it to go through that point exactly. And if I jump out to Desmos again, if I actually type in negative 2 divided by 25, lo and behold, I get exactly the right parabola. So I just have to do that work to get the shape. Okay, so finally, determine an equation to describe the height as a function of distance. This means that therefore y equals negative 2 over 25 times Okay, I'm not going to write x minus 0 all the time, so I'm just going to write x, and I don't even need brackets around it then. So 2 over 25x, and then x minus 40. If you're getting real picky about this, and maybe we should, if the word function is there, you might actually think about it as a function notation. So I'm going to actually call height h, and I'm going to call distance d. I don't really super care about this, but technically height as a function of distance would be given by negative 2 over 25 times the distance minus 40. And that really would be the best answer. Okay. How high is the ball after it's traveled 30 feet horizontally? This is a simple use of my formula. So this is like saying, what is the height after it's traveled 30 feet horizontally? So we use our equation, h as a function of d. I kind of like the function notation, so I'm going to stick with it. I'm also going to try and make my writing a little bit neater. So if we want to solve h as a function of d when d is 30, we would actually put 30 in for d, and that means that everywhere there's a d in my equation, I'm going to write 30, and then I'm going to calculate. Okay, I don't have my calculator with me, so I'm going to try and do this mentally if I can. So this is negative 2 over 25. This is 30. This is negative 10. So I'm going to do a little simplifying if I can. Let's see, so the numerators, so 30 times 10 is 300. 2 times that is 600. The two negative signs will cancel. 600 over 25. When I divide by 25, I think about how many quarters are in 600 or $6, 4 quarters per dollar, so I'm going to think 24, and that's got to be the answer. So 24 feet. And if we want to do this properly, we say the ball is 24 feet at 30 feet horizontally. I could probably write a better sentence, but you get the idea. Just jumping back out, when I go look at this 30 feet horizontally, and I can see that, so when x is 30, y is 24, so there we go, I got it. Okay, here's one more. Meteor crater is parabolic, 4.4 kilometers wide and 800 deep. What's the depth of the crater? 250 from the edge. So this question here is an interesting one. When we think about this, we have a meteor crater, and I'm going to draw a coordinate system where I've got to think about what is the depth of the crater 250 meters from the edge. So for me, this actually makes sense not to start one edge of the crater. Should I start at the origin? I'm thinking, yeah, I'm going to do it. Why did I spend so long thinking about it? I thought maybe I should put it like this and have it symmetric, but I don't know. I'll just keep it like this. So we've got a crater, and it goes something like this. For me, it makes sense to call the top edge, put those on the x-intercept. So the width of it is 4.4 kilometers, but I'm just going to convert that to meters right away, 4,400 meters. And the depth of it is 800 meters. And we would like to know what's the depth. So right here, 250 meters. How deep is it? Okay. So my equation is going to look like y equals a x minus x1 and x minus x2. I'm using factor form again because I've got the same information where the x-intercepts are known. Okay, so what I know here is I know that this guy here is at 0, 0, and this guy here is at 4,400, 0. So this becomes x minus 0, and then this becomes x minus 4,400. Another important point here, probably should draw my picture a little bigger, I apologize, but right here is my vertex. That is going to be halfway between my 2 points, so that is 2,200, and I actually know the way I've drawn it is it's negative 800, so it's below the x-axis there. So what I can do is I can substitute in negative 800 equals, okay, well, let's not switch colors too much. negative 800 equals A. Boy, okay. Oh, I'm getting really excited about some big numbers here. 2200 minus 44. Okay, I don't have my calculator. So this is going to become, okay, so 2200 times negative 2200. Okay, so if you have a calculator, you might actually pick it up now, but I'm going to show you you can do this without. So the way I'm going to do this is I'm actually going to simplify as much as I can. There's a negative sign here and a negative sign here, so let's get rid of it. I'm also going to knock 2 zeros off of this. I'm going to knock 2 zeros off one of these guys. So now I've got 8 equals A times 22 times 2200. Again, I'm going to simplify as much as I can. So I'm going to divide 8 by 2 to make that a 4. I'm going to make that an 11. And I'm actually going to steal this, divide it by 2 out of that. I'm going to divide by 2 over here. So now I've got 2 equals A times 11, 1100 here. Holy smokes. Okay, so what this is going to become is A is equal to whatever 2 divided by 1100 is. Now I'm sitting there going 11 and 11. Well, I know 11 times 11 is 121. So I think I can just do this. I can add a couple zeros at the end, and then finally this is divisible. So this is going to be 2 divided by that. It's going to be 1. Let's see. 12,000 divided by 2 is 6,000. So this has got to be 6,050. There we go. That's my process for how you can do this without a calculator. Okay, so what do I do now? I say y equals A. So let's take this up here. We don't, oh shoot, I don't need to write A. I'm going to write the actual value, 1 over 6,050, x, and then x minus 4,400. Okay, so that's my general equation, and I keep in mind that x is distance from the edge. So remember, x equals distance from the left edge. Not the right edge, although it doesn't really matter. So 250 meters from the edge, I'm going to be substituting in 250. Oh dear Lord. Okay, so this is where even I'm going to look at this and say, I think this is a calculator problem. So what is this? Let's just jump out of here, and I'm actually going to use Desmos. I think it will work. 1 divided by 6050. We're going to multiply it by, no, let's multiply it up top, multiplied by 250, multiplied by 250 minus 4,400. Okay, so when I actually type that in, I'll close up the bracket, but it's already going to be an answer. You can actually see Desmos will work for you. Negative 171 point blah, blah, blah. Let's just round it. So that looks like that's going to be about negative 171.48 or whatever. Squiggly, about 170 meters deep. Now, does that sound reasonable? If the whole thing is 800 meters deep at its lowest point, well, 250, negative 170, that can make some sense. Okay, I believe that is it. Thanks for listening.